Math 2, Tuesday, March 24th, 2020. COVID-19 Distance Learning, Day 2. Imaginary and complex numbers. All right, guys, good morning. We're ready to get started on today's lesson, 11.2, Imaginary and Complex Numbers. Before we get started on that, I know a lot of you are already aware I started a Google Classroom. A lot of you are asking for that. I hope it's working well. A lot of you already signed up, which is great. I sent out the access code in an email yesterday. I'll give that to you again right now. The Google Classroom access code, or class code as they put it, is EYPE3MU. So I'd love if all of you could get signed up for that today. I think it gives you a little better access to our material and our videos. I've already had a lot of questions about, are we going to start turning in our work in Google Classroom? I would like for you to start turning it in. I'm not going to require that. You can either turn it in on Google Classroom, or you can hold on to it and return it to me when we come back from break on April 14th. I'm new to Google Classroom, and so I'm still learning. So if you have things that you like about it that you would like me to start using, or if your other teachers do some things that work well for you, let me know and I'll try and incorporate those. But as of right now, you guys probably know more about it than I do. It seems pretty simple and straightforward, but there's always some tricks to make it better. So let me know if there's anything I can do to change it to make it better. Okay? I will continue to post these videos on my website just in case some of you are having an easier time with that. You can continue to use my website, but eventually we will switch over to Google Classroom exclusively. If you have any questions or concerns, as always, give me an email and I'll try and get right back to you. All right, so let's get started with today's lesson. Today is about complex numbers and imaginary numbers. So let's start off with imaginary numbers. All right, well, we've already have a lot of experience with squaring things because of these quadratic equations. There's always a squared element to it. So let's talk about when we have things squared. We have 5 squared. Well, we know that's 25. And if we have 7 squared, of course, that's 49. Okay? And if we have, let's say, -3 squared, and put that in parentheses, we get 9. And of course, -6 squared is 36. And what you should notice is every time we square a number, whether it's negative or positive, we get a positive number. And that's, something you guys learned a long time ago. Anytime you multiply 2 numbers together, or the same number together, you're going to end up with a positive, because 5 times 5 is 25. A positive times a positive is always a positive. And down here, -3 times -3 is 9, or a negative times a negative is always a positive. So, what is an imaginary number? An imaginary number is basically a number that, if you square it, we're going to call that imaginary number I. Okay, if you square it, you'll end up with a negative number. Now that doesn't really compute for us. That really doesn't make sense, because we know a positive times a positive is a positive, and a negative times a negative is a positive. So how could we square a number and end up with a negative? Well, let's look at it this way. Let's say we could square I, this imaginary number, and we would end up with -1. Okay? Well, we've been doing this a lot. If we take the square root of both sides of this, we end up with the square root of I squared is simply I equals the square root of -1. And that's what an imaginary number is, okay? I, the imaginary number we're going to be talking about, is simply equal to the square root of -1. Okay? And just like above, the next thing we want to talk about is I squared. Well, I squared is simply the square root of -1 squared, which we know squaring and square rooting cancel each other out, so I squared equals -1. Okay, I know that's kind of different and it's hard to really take in, but we do end up with the square root of a negative number quite a bit. And so what we say is the square root of -1 equals I. So anytime we end up with a square root of -1, we simply say, you know what? That really doesn't make sense to us. We're just going to call it I, our imaginary number. So that's an imaginary number. Anytime you have the square root of a negative number, we can isolate that -1 and say the square root of -1 is equal to I. Okay? Now, what is a complex number? A complex number is just a number where you have a real number, say 5, plus an imaginary number, I. So this is an example of a complex number. We could have 7 plus 3i. Or we could have -4 minus 4i if we wanted. Okay, these are examples of complex number. A complex number is just a number that has a real part and an imaginary part. And we're going to be dealing with those quite a bit the rest of this unit. All right, so let's do some examples that you might see on your homework. All right, first, basic one you guys are good at. Start you off with an easy one. What is the square root of 25? Well, that's 5, pretty easy. All right. What is the square root of -25? Okay, well, what we want to do is we want to break this guy up, and we have to go back to a previous lesson. If you remember that the square root of 3 times the square root of 5 is equal to the square root of 15. We just put them under the same roof and multiply them together. But that has to hold true that if the square root of, let's say, I don't know, let's go 2 times 5. Let's say the square root of 10 is equal to the square root of 2 times the square root of 5. So we can multiply these two roots together, or we could actually separate them. And that's what we want to do up here with the square root of -25. We're going to change that to the square root of 25 times the square root of -1. Hopefully you can see where we're going with that. Well, the square root of 25 is simply 5, and the square root of -1 is I. So what we can say is the square root of -25 is simply 5i. All right? Because remember, we know that I is always equal to the square root of -1. All right, let's do a couple more examples. What is the square root of -12? Well, we know it's the square root of 12 times the square root of -1. 12 can be broken down into 2 times 2 times 3. A 2 gets out, a 2 gets killed, and unfortunately that 3 is stuck inside, and of course the square root of -1 is I. So how do we put it all back together? Well, we take the 2, put that out front. We always want to lead with that as a coefficient. Then we take our I and we put it here. And the last thing we do is we put what's left inside. So the square root of -12 equals 2I root 3. All right, let's see. How about the square root of -50? Again, we're not going to always have to do this, but I want to rewrite this as the square root of 50 times the square root of negative 1. This may be the last time I do that. I just want you to remember we can separate these two. And remember 50, square root of 50 becomes 2 times 5 times 5, and this guy simply becomes I. And here on this side, a 5 gets out, a 5 gets killed, the 2 stays in. So the square root of negative 50 equals 5I square root 2. Alright, let's make it a little simpler for us now. Let's do the square root of negative 9. Well, the square root of negative 1 is I, and the square root of 9 is 3, so we get 3I. And one more. Let's go with the square root of negative 75. All right. Well, we know 75 is 3 times 25. And the square root of 25 is 5. So the square root of negative 75 is 5I root 3. Okay, so that's imaginary numbers. Let's go on to complex numbers now. Remember, a complex number is just simply a real number and an imaginary number put together. All right? So, first we can actually just combine imaginary numbers. Let's take 5 minus 3I minus negative 2 plus 4I. All right. So what we're going to do is we're going to distribute this negative and we're just going to combine like terms. So this becomes 5 minus 3I. Negative times a negative is a positive 2. And a negative times a positive is a negative 4I. Now we're just going to combine like terms. We'll combine the real terms. 5 plus 2 is 7. And the imaginary part, negative 3I and negative 4I is negative 7I. And we're finished. Okay? Let's say we have 7 minus 2I. That's one complex number. And we're going to add it to negative 3 plus I. Okay, so we have two complex numbers we're adding together. We don't really need the parentheses because we're simply adding. We can rewrite it, or we could just ignore those parentheses if we wanted. So what do we have? Let's add the real parts together. 7 plus negative 3 is 4. And the the imaginary parts, negative 2 plus I is negative 1I, or just negative I. Okay, so we just did two problems where we combined two complex numbers. Now let's distribute an imaginary number into a complex number, which we can do. So we'll say 3I times negative 5 plus 2I. Okay, we're distributing an imaginary number into a complex number. All right, so remember, distribute, everything gets multiplied by that 3I. So we have 3I times negative 5, which is negative 15I. And we have 3I times 2I, which is 3 times 2 is 6. I times I is I squared. Okay, now you have to remember, what did I tell you I squared equals? I squared equals, well, let's just do it this way. I squared equals negative 1, or the square root of negative 1 squared, which means I squared equals just negative 1. Okay, so we can simplify this one step further. We have negative 15I plus 6, but instead of I squared, we're going to replace it with negative 1. So we end up with negative 15I minus 6. And to clean this thing up, we always want to put our real part first. This is the real part now. So it's negative 6 minus 15I. Okay. Let's do another one like that. Let's FOIL. Let's get even trickier. Let's multiply a complex number times another complex number. So we're going to FOIL here. Fronts outsides, insides, and lasts. Also known as double distributive property. So 4 times negative 1 is negative 4. 4 times negative 2i is negative 8i. 3i times negative 1 is negative 3i. And 3i times negative 2i is negative 6i squared. Okay, let's simplify. Let's combine these two. We get negative 4. That guy's not going to change. Negative 8i plus negative 3i is negative 11i. And negative 6i squared becomes negative 6 times negative 1. A negative times a negative is a positive. We get negative 4 minus 11i plus 6. Last step, negative 4 plus 6 is 2 minus 11i. Are you guys loving complex numbers? I thought so. Okay, well, that should help you out in solving all of worksheet 11.3a. If you have any questions, as always, email me and I'll get back to you as soon as I can. All right, you guys have a great day. Stay inside, social distancing. See ya.